It's called the Ultimate Noise Box and uses a Raspberry Pi to play back dozens of soothing sounds to help you relax or to drown out unwanted noises so you can sleep. In this video, I'll show you how this device works and the many variations on it that you can build, including an awesome 1980s device retrofit. They're also known as white noise generators or sound machines, and they're a great starter project for the Raspberry Pi. But what sets this apart from the ones available online and in stores? Well, I went to a local bed and bath store and I was not impressed by the sound quality or the user interfaces of the ones I found there. Some I couldn't even figure out how to work. I haven't found any other relaxing sound generators that meet my hefty feature requirements. First of all, it has to have CD quality stereo sound and not played through a tiny 3-inch speaker. My model has an analog line level audio out so it can be connected to a nice amplifier or powered speaker. The high quality audio files it plays back are looping and range from 10 seconds to 10 minutes long. The looping is gapless and undetectable, and the files are stored on the device, no network connection required. It has a very intuitive user interface, using this rotary encoder to select a sound, which you can start playing back by pressing in. This button stops the sound, and the other buttons provide presets or instant playback for your favorite sounds. This button cycles through the display. It also has its own web server, providing full browser-based remote control. You can play any of the sounds in the library and also assign them to a preset button with these buttons. Depending on the parts, you can build this for as little as $30, but a full build is closer to $60. This unit has a Raspberry Pi 3A Plus inside and uses that board's audio output, which is fair quality, but good enough for this purpose. However, the even smaller Raspberry Pi 02W has similar specs and is $10 cheaper. So I made a version of the noise box that's about 30% smaller. It has tiny tactile buttons to save space and a small, inexpensive audio DAC hat for even better audio output quality. There's STL files in the linked repo for the 3D printed faceplates that fit standard-sized hobby project boxes. What makes it a great project is that it can run with just a Pi and some amplified speakers while being controlled via the web interface. The rest of the parts should just automatically work as you add them, like the display, the rotary encoder, and the buttons. Both of these units work great, but each needs to be attached to an external amplifier or powered speaker, which can be cumbersome for some setups, especially if it gets moved around a lot. So what would make an attractive, inexpensive enclosure that contains a large speaker that doesn't cost too much? How about the once popular table radio? Table radios were popular in the 1970s and 1980s when you wanted to add some entertainment to a corner of a room. The better ones were nicely designed and had large, full-range speakers. Luckily for us, they are now dirt cheap at thrift stores, if you can find one in decent condition. They're typically $5 to $15 each. This one is the Panasonic RE6290 from 1980. It actually looks and sounds pretty nice, especially on AM compared to today's radios.
Windy with times of clouds and sun.
I'm almost hesitant to retrofit it, but it will actually get more usage by me as a noise machine than as a radio. All we want to reuse from these radios are the case, the speaker, and the original knobs. Everything else must go. So that's what we'll do. Inside, we find standard radio circuitry of the period. including a pretty decent speaker. Removing the main board was easy. These are nice switches, but I'm not going to reuse them. Radio collectors may cringe as I remove the working dial mechanism and tuning string. I need to remove the dial from behind this plastic, and the only way I could get to it was to cut it out. That turned out to be more challenging than I thought. It was a savage process, but I managed to come away with just one minor injury. I designed and 3D printed some brackets to hold the new controls in place. This top one will hold the LCD and the main rotary encoder. The bottom one holds the new volume control and the 2 replacement switches. I'll anchor them with a few internal screws. I'll be installing one of these tiny Class D audio amplifiers that can be controlled via I2C. I mounted the Pi here in the bottom of the case with the amplifier board next to it, attached to the speaker. The power is routed to this jack mounted on the back. I left the old unused transformer in place to give the unit a little more heft. And here's the finished product. The tuning knob is now the main control, and pushing it in plays the selected sound through the unit's really nice built-in speaker. The volume control is still for volume, but now it's a rotary encoder instead of a potentiometer or pot. I like rotary controllers for volume because they don't end up getting dirty and causing noise like pots do. They're just generating pulses, and they can also be used to update the display. But what if we want something even more portable, like for traveling or on vacation? How about a defunct portable radio with a nice sized speaker? This is the Radio Shack 12-625, sold between 1985 and 1993. This one's completely dead, which doesn't matter since we just want the case and the speaker. And this one was being discarded, so I got it for free. Unfortunately, I didn't have time to retrofit it for this video, but you get the idea. Some nice dials here and a great spot for a display. So now that we've built a few versions of the hardware, let's briefly talk about the software. All of the custom code for playing the noises, reading the button presses, and updating the display are written in Python. The Pygame Python library is used to play back the sound files in a loop without any detectable gaps. The rest of the applications used are running in containers. As you may have noticed from some of my other projects, I love using containers. My platform of choice for running containers is Balena, especially for embedded devices like these. On the Balena Cloud dashboard, you can see the different containers running all the different services used by the Ultimate Noise Box. See the GitHub repo for a description of each of these services and how the Ultimate Noise Box project uses them. Now, a device like these that basically plays back sounds at the push of a button can easily be adapted for other similar purposes. I helped a friend of mine fork this project, and with a little modification, it became a simple music sequencer. We built a prototype inside this plastic cookie container. It produces 4 sounds that you can preset with these buttons, and then there's a play and record button. The first rotary dial adjusts the playback tempo, and the other dial is for volume. Here's a quick demo. We're in record mode, and now playback. So that's the Ultimate Noise Box family. It's a good weekend or starter Pi project that's also versatile and can be used as a template for other projects. Let us know in the comments if you end up building one, and I'd also be interested in anyone's experience using any type of noise device. I use this one almost every night, and it's become indispensable to me. That's why I built so many of them, even for friends and family. Anyway, if you found this video interesting and want to see more projects, retrofits, and other tech history, Please click the like button and subscribe to this channel. Thanks for watching.